Hello everyone, welcome to the channel Statistica Hub. So in this lecture we are going to discuss about quartiles. Okay, now let's see them. So in the previous lecture uh, we have talked about range, okay, and we have talked about that if these range contain outliers, then the range are extreme sensitive to the outliers. Because of these sensitivity to the outliers, the range actually got manipulated. Okay, so what we need is a way of negating the impact of these outliers, okay, so that we can best describe how the data is dispersed, okay. Now one of the problem is to look at, like, we can look at the mini range. Okay, now what is mini range is, we have a data set, and we take out the range of this whole data set, and now we are talking about the mini range. Okay, one one that ignores the outliers. It will going to the ignore the outlier. Okay, so our main thing is that we need to get away from these outliers. Okay, now let's see how. So let's say this is the graph that we have, and these are the corresponding outliers in the data. Okay, this is the graph and these are the outliers here. Okay, now we need to get away from these outliers, so we are going to just ignore these outliers. Let's just cut off these outliers from this data. Okay, so take the range of these values, not like these values. We are not going to include the outliers, so we are going to take the range of this much value, not this much value, as we are going to cut off the outliers. Okay, now the question arises is that we are going to, as we are going to just cutting off the outliers. Wait a second, do you mean we pretend the outliers don't exist? That doesn't sound very scientific. Okay, it actually doesn't sound very scientific. Okay, so we need a consistent way of doing this. Okay, now what is that consistent way? Here comes the concept of quartiles. Okay, now one way of constructing a mini range is to just use values around the center of the data. Okay, values around center of the data, though which we can construct the mini range. Okay, now we can construct a range in this way by first lining up the values in ascending order. If we line up the values in, first thing that we line up the values in ascending order. Okay, and then splitting the data into four equally sized chunks, splitting it into four parts. Okay, splitting it into four parts. Okay, now let's say if I have this data like 1 1 1 2 2 2 2 3 3 3 3 3 4 4 4 4 5 5 5 10. Okay, now this is the same data that we have used in the range when it contains an outliers. Okay, now this is the data. Okay, and we have arranged this data in the ascending order. Now what is that? We are going to split this data into four equal chunks. Here, see that we have splitted this data into four equal chunks. Okay, chunks. This is the same data as before, but this time it has splitted into four quarters. Okay, now we can then construct a range using the values that fall between the two outer splits. Okay, now what are these outer splits are? This is said to be the q1. This is my first split, this is q1. Okay, this is the value of q1, and this is the value of q2. This is my second split, and this is my third one, that is q3. Okay, now taking the range between these values gives us the brand new mini range. Okay, now see this, the value that split the data into equal chunks are called quartiles. What are quartiles? Quartiles are the values that split the data into equal chunks, or you can say equal parts, is called as outliers. Okay, as they split data into quarters, that's why we say it quartiles. Okay, now finding quartiles is a bit like finding like the median. Okay, because they show some properties of the median. Instead of finding the values that splits the data in half, we are finding the values that split the data into quarters, that split the data into four parts. Okay, now here the lowest quartile, that is Q1. We have the lowest quartile, which is Q1, is the lower quartile, or you can say the first quartile. Okay, and the highest quartile, we have this highest quartile, which is the Q3. This is my highest quartile, right? This is Q3, and this is said to be the upper quartile. Upper quartile, or you can say third quartile. Okay, and the quartile in the middle, that is the middle quartile, which is Q2. This is actually the median because it is splitting the data into half. Okay, so this is the median here. Now what is the interquartile range? Interquartile range, the interquartile range in these, that is Q1, Q2, Q3, and we have to take out the range from these. Then what will be the range? That is Q3 minus Q1. That's how we find the data range. That is upper quartile minus lower quartile. So the interquartile range will be upper quartile minus lower quartile. Now, the important point to note here is we are not taking the range of the data set like this. We have constructed the data into four chunks, and after constructing the data into four chunks, we have found the outliers, that is Q1, Q2, Q3 in the data, and then we are taking the range of these quartiles, that is interquartile range, okay, which is upper quartile minus lower quartile. Okay, now the interquartile range gives us a standard repeated way of measuring how values are dispersed. Okay, now these are very effective in measuring that how values are dispersed. Okay, so this is the quartile and the interquartile range. So what do we have in the quartile? We have the quartiles. Quartiles are the values that split your data into quarters. That means into four parts. Okay, the lowest quartile is at the lower quartile, which is my Q1, and the highest quartile is called the upper quartile, which is my Q3, and the middle quartile is the median, which is my Q2. Okay, now let's see further that the interquartile range excludes outliers. Let's see how it is excluding the outliers. That the good thing about the interquartile range is that it's a less sensitive to outliers. It's less sensitive to outliers. Okay, let's see that how it is less sensitive to outliers. Okay, so you can see that the upper and lower quartiles, this is my lower quartile and this is my upper quartile. We have taken the same data as we have taken in the first example. Okay, so this is my upper quartile, this is my lower quartile, sorry, this is my upper quartile. Okay, now the upper and lower quartiles are positioned so that the lower quartile has 25% in the data set. Okay, that is 25% of the data is below it. Okay, and the upper quartile has 25% of the data above it. Okay, upper quartile has 25% of the data above it and lower quartile has 25% of the data below it. This means that we are going to consider only 50% of the data. 50% of the data. If you look this closely, then what are our outliers is? Outliers are those that are extremely high or extremely low values. Okay, so if the data has outliers, that has to be, if it is extremely low value, then it will be excluded because of the upper quartile. Okay, and if it is extreme high value, then it will be excluded because of the upper quartile, and here it is for the lower quartile. Okay, so technically we are going to use only the center of the data, that is why we are going to consider only the 50% of the data. Okay, now you can see that we have this Q1, that is a, and below it we have 25% of the data in the set, and we have the upper quartile, and above it we have 25% of the data set. That's how we find the quartiles, that when we divide the quartiles in the data set, then it has 25% of the data below it, and it has a 25% of the data above it. And the interquartile range includes the middle part of the data, that is Q3 minus Q1. It only includes the middle part of the data set, and but excludes the two outer quarters where any outliers live. Okay, it is excluding the quarters that are contains outliers, that is extremely high values will be included in this one, and extremely low values will be included in this one. So it is including these outliers. Okay, now as the interquartile range only what 50% of the data, 50% of the data. Now, outliers are excluded irrespective of whether they are extremely high or extremely low. Okay, we don't know whether it is going to consider only 50% of the data. We don't know whether the outlier is extremely high or extremely low values, but it is for sure that these outliers can't be in the middle. Can't be in the middle because outliers are only extreme high or extremely low values. Okay, so what does this mean is that any outlier in the data are effectively cut out like this. We are going to cut out the outliers. That is, if this is the graph that we have like this one, okay, then it is going to cut out the outliers. The outliers are always extremely high or extremely low values. So extremely high values will be cutted into this part, that is upper quartile, and extremely low values will be cut out into this part, which is lower quartile. Okay, and we have the remaining part, that is my 50% of the data, of the data. Okay, now excluding the outliers with the interquartile range means that we now have a way of comparing different sets of data without our results being distorted by outliers. Okay, so we can like measure the data, we can know how the data is dispersed by excluding the outliers. Okay, now let's just see what does it say. We have the interquartile range, which is said to be the mini range, a mini range that sends less sensitive to the outliers. You find it by upper quartile minus lower quartile, that is Q3 minus Q1. Okay, now let's understand the quartile anatomy, that how can we find the quartiles, how these values of the quartile, that is Q1, Q2, Q3 are being finded out. Okay, now finding the quartiles of a set of data is like similar process finding the median. We know that how to find the median in the previous lectures too. Okay, so let's see that if you have n numbers, okay, if you have n numbers, it's the number that's at the position like n plus 1 divided by 2. Okay, and if this falls halfway between the two numbers and you take their average, okay, this is what the median is, that we have if you line up all what we do in this, if you line up all your values in ascending order, the median is the value right in the very center. Okay, this is the median that we have. So if we have n numbers, then it's the number that is at the position n plus 1 divided by 2, and if this falls like n halfway in between the two values, then we take the average of these two values, right? That is the average of n by 2 and n by 2 plus 1th position. Okay, that's how we find the median. Now if we then further split the data into quarters, then how can we find these values? Let's see that. Okay, so in the quarters we have something like this, that we are splitting the data into 4 parts, that is first part, second, third part, and this is my fourth part. Okay, now we are going to find out the values that are lying in between. Okay, now this is my lower bound, this is upper bound, the values between them is the upper quartile, this is median, and this is lower quartile. Okay, now finding the position of the quartiles is slightly trickier than finding the position of the median. Okay, now but it's not that hard, you can gain it very easily. Okay, now we have to find the positions of these values, that is q1, q2 and q3, finding the position, that how these data are actually going to be split out. Okay, so let's just talk about how to find the position of the lower quartile. Okay, so finding the position of the lower quartile, first step what we do is start off by calculating n divided by 4. Okay, whatever the number you have, n divided by 4. Okay, and then second step is, if this n divides by 4 gives you an integer value. Okay, if this is an integer value, then the lower quartile will be the that integer value between this position, that the integer value position, and the next position's average. Okay, just like the median, if we have the integer value, then what is the lower quartile is, let's see it here, it is halfway between this position, that is integer's position, whatever the position integer value gives, okay, this position, and the next one. That is, we have to take out the average of the numbers at these two positions. That is, if my number is, say, let's say 8, okay, then n divided by 4, that is 2, that is 2, and this is a complete integer, so my quartile will lie between second position and third position average. I have third position and second position, we got second and third position, and we have to take out the average of these second and third positions data. So as we are saying, it has 8, so if this is my data set, 1 1 2 2 3 3 3 1 2 3 4 5 6 7 8. Okay, now what is the second position? Second position is this one, and third position is this one. So what is the average of this? That is 1 plus 2 divided by 2. This is 3 by 2. Now this is the value for the lower quartile. Okay, you got it, that how we understand, how we can find the value for the lower quartile. Now this is the case of integer. Now this is also possible that if n divides 4, this is not an integer. Okay, now if the value is not an integer, and in this case we are going to round it up, we are going to round the values, then this will give us the position of the lower quartile. So if the n divides 4 come like 4.75, then it will be like it will be like fifth position, and my fifth position is going to be the lower quartile. Okay, okay, so what is the condition, or how we can find the upper quartile? Similarly, go for the upper quartile. For the upper quartile, we do 3n divided by 4. 3n divided by 4, we are going to calculate this part. Then, if 3n divided by 4 is an integer, if this gives an integer, then the upper quartile is positioned between the halfway between the this position and the next one positions data average. We are going to take the average of these two positions data. Okay, now if this is not an integer, if 3n divided by 4 is not an integer, then in that case we are going to round up the values, and this new number gives us the new position for the upper quartile. So it will be like 4 point, like not always 4.5, it will be like 1.5, then my result will be like 2, second position. That's how we are going to round it up. Okay, now let's do an example that how we can find the values for the upper and lower quartile. Okay, this is an example. Let's understand the quartiles by a problem. Okay, so here we have given points scored per game and the frequency. Okay, so we have done this example in the range 2. We are going to consider this in this case. Okay, now the first question that we have asked is, what is the range of this set of data? What's the range? So what is the range? For the range, we have to find the lower bound, like lower bound and upper bound. Now, what is my lower bound here? The lower bound of this set of data is 3, that is the lowest value, and the upper bound, that is the highest value in the data set, that is 30. You can see that this is the 30. So my range would be as the range is upper bound minus lower bound, so it will be 30 minus 3, that is equals to 27, right? So my range here is 27. Now the next question it has asked is what are upper and lower quartiles? Okay, now let's start with the lower quartile. Lower quartile. Okay, so applying like the previous case, so we what are the numbers and we have n. What is n? N here, as we have the frequency here, so n will be the sum of the frequencies. What is the sum of frequencies? Like 2, 1, 3, 5, uh, okay, 9, 10, 11. So n is equals to 11 here. Okay, as my n is 11, so what do we have to do? 11 divided by 4. If we divide 11 by 4, then what does it come? It will be like 4 to the 8, 2.75. Okay, it will be 2.75. So this is not an integer. It is not an integer. So we are going to round it up the values and the value will be 3. Okay, so rounding this number gives up the position of the lower quartile. So the lower quartile is at the position 3. This means that which is one is a 3 position. So if we arrange them in the ascending order, then 3, 3, 6, 7, 7. As this is the frequency, it is like it is being going to be repeated into twice. Similarly goes for this 10, 10, 10, 11, 13, 30. Now which one is the third position? Third position is 6, 1, 2, 3. Okay, so my lower quartile I got is 6. Okay, this is my lower quartile. Okay, now let's talk about the upper quartile. What is the upper quartile here? For the upper quartile, what do you have to do? We divide 3n divided by 4. Okay, that is 3 into 11 divided by 4, which is 33 divided by 4. Now what is 33 divided by 4? 4 to the 8. Okay, 4 is a 32. 8. 2, 4 to the 8, 2, 5, 5, 4, 4 actually. Okay, so it is 8.25. Okay, now as it is also not an integer, so we are going to round it up the values and the value is 9th. So we are going to find the upper quartile at the 9th position. Now which one is the 9th position? That is 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 11. 11 is my upper quartile. Okay, now what is the median here? If I take out the median, then what is the median here? The median is n plus 1 by 2, so it will be at the median, or you can say the middle quartile, second quartile, that is q2. Okay, what will be the median? That is how we find the median, n plus 1 by 2, that is 11 plus 1 by 2, which is the 12 by 2, so which is the sixth position. Which one is the sixth position? 1, 2, 3, 4, 5, 6. This is my sixth position. So we got lower quartile, middle quartile, that is median, and the upper quartile, that is q3. So we got q1, q2, q3. Okay, and what do we have to find? We have to find the what are upper and lower quartile. So we got upper quartile is 11 and lower quartile is 10, and the median is median is 10 and the lower quartile is 6. Okay, these are the corresponding values that we got. Okay, now let's look at the next question that is asked, that what's the interquartile range. So we got Q3 that is equals to 11 and Q1 that is equals to 6. Okay, and what is the interquartile range? That is interquartile range is equals to Q3 minus Q1, that is equals to 11 minus 6, which is 5, right? Now this is much lower than the range as it excludes outliers. Okay, because how it is much lower than the range? Because if we have taken out the range of this data, range, then what will be the range of this data? That is highest value 30 and the lowest value that is 3. Okay, so the range will be upper highest value minus lowest value, so that will be 27. The range is quite high, that is 27, and we got the interquartile range by using the quartiles is 5. So it is much lower than the range as it is excluding the outliers. Okay. Now the question arises is, should I always use the interquartile range to measure the spread of data? Okay. Now what is the case in that? In this case, that in a lot of cases, the interquartile range is like quite meaningful, is more meaningful than the range, but it all depends on what information you really need. There are other ways of measuring how values are dispersed that you might want to consider too. Okay, and we are going to discuss these other ways in the next lecture. Okay, so it all depends on your data, that what type of data you have, and according to that we are going to apply the types of dispersed data, that is range or quartiles, anything you want. Okay, but it is for sure that interquartile range are more effective than the range. Okay, now what is the next question? The next question is, so is the median the same as interquartile range? We are saying that is the median the same as interquartile range? Range. Okay, the answer is actually no. The median is the, what is the median? The median is the middle value of the data. Middle value of the data. Okay, and the interquartile range is the range between 50% of the data. Range between, range of the, or you can say range of the 50% of the middle 50% of the data. Middle 50% of the data. So they are actually quite different. When we have a data set, okay, then finding out the middle value of this data set is the median. Okay, and we have a data set and we take out the 50%, middle 50% of the data set, middle 50% of data set, and then take out the range of this middle 50% of the data set is the interquartile range. So these are like so much different from each other, they are not same. Okay, median and interquartile range are absolutely different. This is middle value of the data and this is middle 50 this is the range of the middle 50% of the data set. Okay, that is like this one. We have lower q1, q2, q3, q1, q2, q3. So this is the range of q3 minus q1, that is range of this data set. Okay, as we are going to exclude other data set, that is we are going to consider only 50% of the data set. We are not including these 25%. Okay, okay, so what is the next question arises, that how about breaking my data into 10 pieces instead of 4? Okay, so we have in the quartiles, we have splitted the data into 4 parts. Now the question is that, can we split the data into further parts? Okay, yes you can. We can split the data into further parts. There are many times when you want to do this, that when you have outliers, it will like, when you have like data that is much big, then you have weight data something like this. Okay, then you are going to uh, split the data into more parts, that you can say 10 parts. If you are going to split the data into 10 parts, then it is said to be the deciles. Okay, and if you are going to split the data into in terms of percentiles, then it is said to be the percentiles, and we are going to discuss this in the further lectures too, that what are deciles and what are percentiles. But the thing is that you can split the data into further parts, into more further parts, that is in the quartiles we split the data into 4 parts, in the deciles we are going to split the data into 10 parts, and in the percentiles we are going to split the data into according to the percentage. Okay, 10%, 20%, 30%, like this. Now, what is the whole concept that we have studied till now? That is, the upper and lower bounds of the data are the highest and lower values in the data set, right? The upper bounds and lower bounds in the data set. This is the upper data set, then this is the lower bound, and this is the upper bound in the data set, and this is the lower bound is lowest value and upper bound is the highest value in the data set. The range is a simple way of measuring how values are dispersed. It is given by range is equals to upper bound minus lower bound. It's absolutely right. That range gives us range is very simple to understand. That's why we use range, because it is easy to understand. Okay, and the range is upper bound minus lower bound. Okay, the range is very sensitive to the outliers. Yes, the range is very sensitive to the outliers. Because the range is very sensitive to the outliers, we have introduced the concept of the quartiles. Okay, the interquartile range is less sensitive to the outliers than the range. Yes, we have done this, that in the example we got 27 the range of the same question, and we got the interquartile range as 5, because it has excluded the outliers. Okay, so it is less sensitive to the outliers. It is also true. Now, quartiles are values that split your data into quarters. The highest quartile is called the upper quartile. It will be somewhere like Q3. This is the highest quartile, and the lowest quartile is called Q2, Q1, and the middle quartile is said to be the median, that is Q2. Okay, and what is the interquartile range? Interquartile range is the range of the 50% of the data, that is between Q1 and Q3 data, and it is going to include this 25% of the data. This is upper 25% and lower 25% of the data. It is going to exclude it, because it is going to exclude the outliers, and it is going to consider only 50% of the data, and we are going to find the range of this middle 50% of the data set, and that is upper quartile minus lower quartile. Okay, so here is the summary of these previous two lectures. This is the summary of these previous two lectures. Okay, now in the next lecture we are going to discuss about the deciles and percentiles. Sorry, percentiles. Okay, thank you for this lecture.